Hey everybody. Today we're talking about confidence intervals for proportions and the sample size needed to attain a specified margin of error. So here's the formula for a confidence interval for a proportion. You estimate the population proportion p using a point estimate of the sample proportion p hat and a margin of error of z star square root p hat times 1 minus p hat over n, where n is the sample size and z star is the critical z-score needed for the confidence level C that you've specified. So if we take that formula for the margin of error and we do a little bit of algebra and solve it for n, I'll spare you those steps, we get the formula at the bottom here. P hat times 1 minus p hat z star squared over e squared. So on the surface it appears we can just plug into that to get the n when we know our e. Unfortunately, the situation where we really want to use this formula is when we're in the planning phase of a study, when we're determining what kind of sample size we're going to need in that study. So we don't yet have access to p hat. We're going to have to estimate it somehow. And fundamentally, there are two ways to do this. First of all, you can use data from a previous study, like a pilot study, for instance, as an estimate for p hat. If you don't have access to that or don't want to rely on that, then you want to use the most conservative possible value for p hat. That is, the one that produces the largest n when you plug into this formula. So what I'm going to do is view e and z star as fixed and graph n as a function of p hat. P hat, of course, can go from 0 to 1. And the plot is a parabola that opens downwards with x-intercepts, or I guess p hat intercepts at 0 and 1. And the maximum value occurs at p hat equals 1/2. That's going to be the most conservative value of p hat that you can use when choosing your sample sizes. When in doubt, that's the value we should use in our sample size calculations. If we plug p hat equals 1/2 into the formula that I showed a moment ago, things simplify down and we get z star squared over 4e squared as our formula for the sample size n needed to attain a margin of error of e. Let's wrap up with an example. How large a sample is required to conduct a survey with 95% confidence if the margin of error can be no larger than 3%? I recommend pausing the video here, trying this on your own before seeing my solution. We don't have any preliminary data, so we want to use the most conservative estimate for p hat, 1/2. The formula is z star squared over 4e squared. We're going to use z star as 1.960. That's the critical z-score corresponding to a confidence level of 95%. We plug in, we do a little bit of algebra, we get 1067.1. Now, sample size needs to be an integer, so we have to round this. It seems like we should round it down, but that's actually not the case. When computing the sample size for a given margin of error, we always round up, even if the value is pretty close to the next value down. And the reason for this is that increasing n decreases the margin of error, while decreasing n increases it. So those two have an inverse relationship. So any n less than 1067.1 will give us a margin of error greater than 3%, and that's not allowed. 3% is our maximum allowed margin of error. Therefore, we have to increase this margin of error, round up to an n of 1068. And that's the sample size we should use when planning this study.